since we launched this lecture series in June 2018. Since then, we have been able to conduct lectures periodically without any interruption, covering the ongoing researches in higher sciences. Our participants are mainly students, researchers, professors, science activists, and those who got an interest in science but missed to have the science as their career. Today's lecture is going to be in neuroscience. We have Dr. Reeteka Sud with us from NIMHANS with us. I welcome you, ma'am. A brief introduction about the PSL and Tamil Nadu Science Forum shall be given by Dr. Seduraman, the state coordinator for the subcommittee on science propaganda. On behalf of PSL, I welcome you, sir. The speaker shall be introduced by Dr. Ramanujam, a professor in IMSc, an important leader of Tamil Nadu Science Forum. I welcome you, sir. This lecture shall be for 45 to 50 minutes and it shall be in English. A brief Tamil version shall be provided by Mr. Sellakumar, Chief Engineering Designer, Tamil Nadu Electricity Board. As many of our participants are from interior district of Tamil Nadu, I welcome you, sir. After this, we have an hour-long question and answer session. Ever since the pandemic session season, we have switched over to the web-based lectures. We expect you to follow a few ground rules to conduct the session smoothly. All the participants' mic shall be muted. We expect you to bear with us. During the question answer session, you can raise your hands and chat with the speaker directly or write your question in the chat box. The question on the chat box shall be read one by one and the answer shall be provided by the speaker. We expect you to ask questions related to the speech given by the speaker and do not express your opinion on the subject. Please find the link in the feedback forms in the chat box. We request you to fill the feedback forms immediately after the meeting is over, as it will help us to review and improve our activities. Before I hand over the mic to Dr. Seduraman, let me make my announcement in Tamil. தமிழ்நாடு அறிவியல் இயக்கத்தின் வெகுஜன அறிவியல் சொற்பொழிவு தொடர் கிளையின் சார்பாக உங்களை வரவேற்கிறேன். இது எங்கள் கிளை கடந்த ஜூன் 2018 துவங்கியதிலிருந்து நடைபெறும் 32வது நிகழ்ச்சியாகும். அன்றிலிருந்து நாங்கள் இடைவிடாது தொடர்ச்சியாக இந்த நிகழ்ச்சியை நடத்தி வருகிறோம். மாணவர்கள், ஆய்வாளர்கள், பேராசிரியர்கள், அறிவியல் ஆர்வலர்கள், அறிவியலை தொழிலாக கொள்ளும் வாய்ப்பை இழந்தவர்கள் ஆகியோர் எங்களது நிகழ்ச்சியில் தொடர்ச்சியாக பங்கெடுத்து வருகின்றனர். இன்றைய சொற்பொழிவானது மனித மூளையியல் அறிவியல் ஆய்வை மையமாக கொண்டது. பெங்களூரில் இயங்கி வரும் ஆய்வு நிறுவனமான நிம்ஹான்ஸில் பேராசிரியராக பணியாற்றும் முனைவர் ரித்திகா சூத் சொற்பொழிவை நிகழ்த்த வந்துள்ளார். அவரை அறிவியல் இயக்கம் சார்பாக வரவேற்கிறேன். வெகுஜன அறிவியல் கிளை பற்றியும் தமிழ்நாடு அறிவியல் இயக்கம் பற்றியும் ஒரு சுருக்கமான அறிமுகத்தை வழங்குவதற்கு முனைவர் சேதுராமன் வந்துள்ளார். முனைவர் சேதுராமன் தமிழ்நாடு அறிவியல் இயக்கத்தின் அறிவியல் பிரச்சாரத்திற்கான உபகுழுவின் மாநில ஒருங்கிணைப்பாளர். அவரை அறிவியல் இயக்கத்தின் சார்பாக வரவேற்கிறேன். இந்த சொற்பொழிவானது ஆங்கிலத்தில் நடைபெறும். சுமார் 45 நிமிடங்கள் முதல் 50 நிமிடங்கள் வரை நீடிக்கும். அதன் பிறகு இதன் சுருக்கத்தை 10 நிமிடங்களில் தமிழில் திரு செல்லக்குமார் அவர்கள் வழங்குவார்கள். திரு செல்லக்குமார் தமிழ்நாடு மின்வாரியத்தில் முதன்மை பொறியியல் வடிவமைப்பாளராக பணியாற்றி வருகிறார். அவரை அறிவியல் இயக்கத்தின் சார்பாக வரவேற்கிறேன். அவருடைய சுருக்கமான உரை முடிந்த பிறகு சுமார் 1 மணி நேரம் கேள்வி பதில் பகுதி நீடிக்கும். தொற்று காலம் துவங்கியவுடன் எங்களது இந்த சொற்பொழிவுகள் இணையதளத்தின் வாயிலாக நடைபெற்று வருகின்றன. இணையதளத்தின் பங்கேற்பாளர்கள் சில விதிமுறைகளை பின்பற்ற வேண்டும் என்று எதிர்பார்க்கிறோம். சொற்பொழிவு நடைபெறும் பொழுது உங்களது மைக் நிறுத்தி வைக்கப்படும். உங்களது கேள்விகளை செயலியில் உள்ள சாட் பாக்ஸில் பதிவு செய்யுங்கள். கேள்விகள் ஒன்றன் பின் ஒன்றாக படித்து பதில் வழங்கப்படும். பேராசிரியரோடு நேரடியாக கேள்வி கேட்க விரும்பும் நண்பர்கள் உங்கள் கையை உயர்த்தவும் ஒருவர் பின் ஒருவராக வாய்ப்பு வழங்கப்படும். உங்களது கேள்விகள் சுருக்கமாகவும் சொற்பொழிவு சம்பந்தப்பட்டதாகவும் இருக்க வேண்டும். உங்களது கருத்துக்களை இங்கே பதிவு செய்ய வேண்டாம். நாங்கள் சேட் பாக்ஸில் ஒரு இணைப்பை கொடுத்துள்ளோம். அது உங்களுடைய கருத்தை பதிவு செய்வதற்கான இணைப்பாகும். அந்த இணைப்பை சொடுக்கி உங்களுடைய கருத்தை பதிவு செய்யுங்கள். உங்கள் கருத்துக்கள் எங்களை செழுமைப்படுத்த உதவும். முனைவர் சேதுராமனை சுருக்கமாக அறிவியல் இயக்கத்தை அறிமுகப்படுத்துமாறு அழைக்கிறேன்.
குட் ஈவினிங் டு ஆல். அனைவருக்கும் அறிவியல் வணக்கம். தமிழ்நாடு அறிவியல் இயக்கம் 1980 துவங்கப்பட்டு அறிவியல் மக்களுக்கே, சயின்ஸ் ஃபார் தி பீப்புள், சயின்ஸ் ஃபார் தி நேஷன் என்ற கொள்கையுடன் செயல்பட்டு வருகிறது. இந்த தமிழ்நாடு சயின்ஸ் ஃபாரம் அறிவொளி ஆரம்பிக்கப்பட்டு ஆணுக்கு பெண் நிகர் என்ற அடிப்படை கருத்துடனும் செயல்பட்டு வருகிறது. அதன் அடிப்படையில் பல பரிணாமங்களை கடந்து தமிழ்நாடு அறிவியல் இயக்கம் இன்று ஒரு 6 முக்கியமான தளங்களில் பணியாற்றி வருகிறது. அதில் கல்வி குறித்து, கல்வி உயர்கல்வி குறித்து பணியாற்றி வருகிறோம். அதே போல அறிவியல் பிரச்சாரம் என்ற வடிவத்திலே அறிவியல் சார்ந்த கருத்துக்களை இங்கே வழங்கி வருகிறோம். அதே போல ஆண் பெண் சமத்துவத்தை உணர்த்தும் வகையில் சமம் என்ற ஒரு உபக்குழு வைத்து செய்து வருகிறோம். அறிவியல் சார்ந்த பல கருத்துக்களையும் பல நூல்களையும் குழந்தைகளுக்காக துளிர், ஜந்தர் மந்தர், விஞ்ஞான சிறகு, அறிவுத்தென்றல் இது போன்ற பத்திரிகையை தொடர்ந்து நடத்தி வருகிறோம். அதற்காக அறிவியல் வெளியீடு சயின்ஸ் பப்ளிகேஷன் என்ற ஒரு அமைப்பு உருவாக்கி நடத்தி வருகிறோம். அதே போல நிலம் நீர் விவசாயம் சம்பந்தமான ஆய்வுகளை தொடர்ந்து நடத்தி வருகிறோம். அதற்காக டெவலப்மெண்ட் வளர்ச்சி என்ற ஒரு உபக்குழு வைத்திருக்கிறோம். பள்ளி மாணவர்கள், கல்லூரி மாணவர்கள் இணைக்கும் வகையில் துளிர் இல்லம் மற்றும் இளைஞர்கள் சயின்ஸ் ஃபார் தி யூத் ஃபார் சயின்ஸ் என்ற ஒரு அமைப்பையும் நடத்தி வருகிறோம். வேறு 6 தளங்களில் வேலை செய்து வருகிறோம். அதில் அறிவியல் பிரச்சாரத்தில் இந்த பாப்புலர் சயின்ஸ் லெக்சர் என்ற ஒரு செயல்பாட்டு வடிவத்தை சென்னை மையமாக வைத்து நடத்தி வருகிறார்கள். அதனுடைய தொடர் செயல்பாடுகளாக இன்று 32வது சொற்பொழிவு நடைபெறுகிறது. அறிவியலை எளிமைப்படுத்தி மற்றும் உலகம் முழுவதும் உள்ள அறிவியல் சார்ந்த கருத்துக்களை மக்களிடம் கொண்டு செல்ல வேண்டும் என்ற ஒரு உயரிய நோக்கத்துடன் இந்த பாப்புலர் சயின்ஸ் லெக்சர் டீம் வழிகாட்டி செயல்பட்டு கொண்டிருக்கிறது. இதன் வழிகாட்டிகளும் இந்த அறிவியலை துவங்கிய காலத்திலிருந்து செயல்பட்டு வரும் செயல்பாட்டாளர்களும் இந்த பாப்புலர் சயின்ஸ் லெக்சரை வழிகாட்டி வருகிறார்கள். அதன் அடிப்படையிலே இன்றைய நிகழ்வுக்கு அனைவரையும் அன்போடு வரவேற்று தமிழ்நாடு அறிவியல் இயக்கம் பற்றிய உரையை இத்துடன் நிறைவு செய்கிறேன். வாய்ப்புக்கு நன்றி, வணக்கம்.
Thanks, Mr. Dr. Sethuraman. I invite Dr. Ramanujam to introduce the speaker.
Thank you. Thanks, Vijay. அனைவருக்கும் வணக்கம். இன்றைய உரையாளரான முனைவர் ரீதிகா சுட் அவர்களை அறிமுகப்படுத்துவதில் நான் மிகவும் மகிழ்ச்சி அடைகிறேன். பெங்களூரில் இருக்கக்கூடிய மூளையியல் துறையில் நிபுணர் அவர். Reeteka is a neuroscientist and research coordinator of the Adbs lab at NIMHANS, Bangalore. இந்தியாவின் தலை சிறந்த ஆராய்ச்சி நிறுவனங்களில் ஒன்றானது NIMHANS. It's one of the class institutes of country involved in research in mental health and neurosciences. And her research interests include stem cell models to understand psychiatric disorders. And she's not only an expert in the researcher, but she's also an excellent science communicator and passionate about science communication and education. Also about women in science. She's part of the 500 WS group, is an eLife ambassador, and one of the founding members of the Indian Scientist Response to COVID-19, where several of us here in this group have worked with her. Her articles have been featured in science magazines like I Wonder, The Wire, The Hindu, Times of India, and many other places. She's worked with the IndiaBioScience Education Coordinator and the CUBE program as faculty advisor. This is from the Baba Science Center for Education. She's an alumnus of the Perelman School of Medicine at the University of Pennsylvania in the United States. And when she was working there, she was awarded the Young Investigator Fellowship by the Alzheimer's Drug Discovery Foundation of New York. So, as I said, Reeteka is passionate about science communication and education. It's a great pleasure to welcome her to Tamil Nadu Science Forum and request her to lecture here. Reeteka, again, Tamil Nadu Science Forum is also another group where there are many people here who are passionate about science communication and education from different parts of Tamil Nadu. There are many teachers here, undergraduate students here, and it's a mix that welcomes you very warmly. And we are eagerly looking forward to your lecture as well as having you participate in Tamil Nadu Science Forum activities. Thank you. Over to Reeteka.
Thank you. Thank you so much for the kind introduction and for inviting me to talk to you today. I have been in love with the brain since I was, I think, 12 years old. So it's really exciting for me to talk about that with all of you today. So we'll talk about like the basics of what the brain does and how it does, how we know what it does, and so on. So I want to start with a little game, if you will. So if I show you this image, you can see, yes? You can see the screen? Okay. So in this image here, if I were to ask, what do you see changing here? Everyone will be able to see this bag right here that appears and disappears. So this is what's different. This is what's changing here. But if I were to show you this image here and ask you what's changing, it might take a while. It will, unlike the image on the top, which was very easy to stop, to spot the change. Here, the image is flickering, and that is to coincide with what the blinking of our eyes. So if a change happens in our vision field and the change coincides with blinking of an eye, you can miss the change. So I'll just point out here, there's this engine under the wing appears and disappears with the flicker of an eye, with the flicker of the image. So even if you were able to spot it, I bet it was hard to see that. And that's to coincide with the flickering of the image. So although our brain does a phenomenal job most of the times to figure out what's going on, but sometimes even huge changes can be very difficult to spot. And that's kind of what I meant to indicate with the title of what it can and cannot do. So let's just, so we'll talk about, the basics of the brain and the structure and how it does what it does. And despite, it's a work of ingenuity, how the brain is put together and how it's able to do what it does. And sometimes, and this is going to be our part 2 here of sometimes even with incredible machinery, something doesn't quite go right. And we'll talk about some examples of that. And finally, we'll conclude with some recent techniques of how we study what goes wrong with the brain in the context of psychiatric disorders and other brain disorders. So here we have, this is the overall view of the brain. So we're looking at it from the from below. So brain taken out of its skull and held up. You would say this is here is the cortex part, the cerebellum, brainstem. So here, this is the brain inside the skull. So we see a section of that skull, and it is protected from the environment, from the skull itself, with these layers you see here in pink and gray. And these are called the meninges. And underneath the meninges, you see here, there's a thick network of blood vessels. Brain in of itself is really very, very soft tissue, like the consistency of a, you would say, an overripe fruit. It's very soft. So to protect it and to keep it in place, the meninges do that job. The development of our brain is incredibly long, extremely protracted. It starts in the first month of pregnancy. It starts the formation like a tube here, and then over the course of the pregnancy, you see the front end of the tube protracts, and this is where the brain would form. In the initial stages, it's smooth, almost like this is what a mouse brain looks like, actually, the smooth on the surface. And then as the pregnancy goes on, development continues, it develops these characteristic folds. And then by the time a child is 6 years old, the brain has reached about 90% of its size. But the development itself, brain growth, continues till you're in your mid-20s. So that to me is a sobering thought. If you live to, let's say, be 75, a third of your life, your brain wasn't even fully online. It takes that long for it to fully develop. It does continue to change even after that, but then just the development part takes a good 25 years. So why do we have it? Like, what does it do? So the basic things of it helps us make sense of what we see around us. Yeah, the information that is coming in through the senses, sensory information, sight, sound, smell, etc. It helps us place where we are and navigate our immediate surroundings. And these are some of the, so just these basic functions, these have been the subject of Nobel Prize in the recent past. So Nobel 2004 was given to Linda Buck and Richard Axel for figuring out how the sense of smell, the odor perception in the brain, how that works. Then 2014, we have John O'Keefe, May Britt Moser, and her husband Edward Moser, who collectively figured out this system, what's now called the inner GPS, how the brain figures out where you are and how you should get from point A to point B and so on. So like I said, these are the basic fundamental thing of what a brain does. And even those things are, just the fact that the timing of these tells you that we're barely scratching up at the surface of how the brain does its basic fundamental functions, let alone, heavyweight topics like how diseases develop and consciousness and all, dreams and so on. There is so much that we don't know about this incredible organ. So I want to start with talking about some of these basic functions of what we do know about how it works. So beginning with the odor perception. So Linda Buck and Richard Axel used the mouse to figure out the sense of smell to this part of the brain function. And for rodents, their life is pretty much eat, mate, run. And when to do which is largely dictated by sense of smell. Who or what you smell. Is it something you can eat or something that can eat you? So olfaction, smelling, figuring out the smells in the immediate environment is a big part of their life. So it's not a surprise that the olfactory bulb, the part of the brain that does that, is a big part of rodent brain. So here we see that in front of the brain, and then this is how it is placed in the head of the animal. So in us, the sense of smell is, basic building blocks are the same, but the brain part is slightly different. Here in the really far up in the nose are the nerve endings which connect with the olfactory bulb. And this then sends a signal to olfactory cortex, which tells you what you smell, identifies the smells, and also to the limbic system. We've all experienced that smell can be a powerful trigger of memory. So this is the circuitry that helps bring that about. So these guys helped to figure out not only the circuitry, how in the brain this is figured out, but also the cellular part of it, the individual cells, how they work, how they identify the odors. So as it happens, the cells that we have up in the nose, each cell has thousands and tens of thousands of these proteins on the surface called receptors. And one cell will have only one kind of receptor. And one receptor will figure out only one part of an odor. And then the brain sort of pieces all these together. If what you smell is a mixture of odors, each cell with all its receptors will identify one piece of it. And then the brain will sort of put all these together. And that's how we're able to identify the smells and remember smells from previous experience and so forth. Moving on, so the inner GPS. So like I said, John O'Keefe, who was one of the scientists who back in 1970 sometime, he figured out the first piece of this inner GPS. So here, this is one of how he figured it out, identified it, was what we call a happy accident in science. So he was actually studying the part of the brain which gets the sensory information. And one day the electrode, so what you do is you put an electrode in the brain, and when brain cells talk to each other, the language they use is the language of electricity. So when a nerve cell fires, you can measure the electricity coming out from that cell. So one day that electrode went a little bit off to the side, outside of the part that he was called the thalamus, where he was originally studying, and went into the neighboring part called the hippocampus. And so as a result of that, what he found was the hippocampus has cells that fire when the animal is at a particular part in this box that it is put in. So for example, in this example, when the animal is at point A, this one cell fires a lot. And then in between, when it is at other points, C, D, E, and so on, nothing. And the animal comes back to A and the cell fires again. So this to John O'Keefe was really interesting, that this is a cell that tells the brain where the animal is at. And so for the other locations, there will be other cells that fire at respective places. So it's the electrical activity of these cells that put together that the part of this brain called the hippocampus can help figure out where you are. The second piece was identified by the Mosers many years later, and they found out in the part, another part of the brain next to the hippocampus called the entorhinal cortex. So that's this part in the blue here. This has cells where that have a complementary function. So if we see here, the black lines here are the traces as a mouse sort of makes its way inside a grid. This is how it's moving. And red is the place cell, the cell in the hippocampus, which is this part in the pink here. The one cell will fire only at one particular area, whereas the cells called grid cells, which are here in the entorhinal cortex, they fire at multiple locations. And this is the pattern that makes. And so if you look at it, it kind of makes like a hexagonal grid, which is why they're called grid cells. And it's the activity of these two cells put together that helps the brain to figure where you are at any given point in your immediate surroundings, how to go from point A to point B, and so on. So as you see here, this parts are quite deep into the brain, and this is the part that's common, that works the same way in mouse as it does in our brains. So let's talk more about the hippocampus, this pink part right here. So actually, when O'Keefe started working on, when he did his first experiments when identifying the place cells, the only thing we knew about the hippocampus was that it has something to do with memory formation. And how we knew that was because of, in large part, courtesy to this man, Henry Molaison. Henry, when he was a child, he had an accident. And a few years later after that, he started getting seizures. And even though they were managed by medication for a long time, they progressively kept getting worse. And by his mid-20s, he couldn't, they were very, he was incapacitated, he couldn't hold on a job. So his neurosurgeon suggested an experimental surgery. So in that, what they did was they removed the part of the brain where he was getting seizures. So this here, this is the underside of a normal brain. And this is a sketch of what the HM's brain, Henry's brain was. So you see this entire part here, this was removed in his brain. This is a section. Now, if you were to say cut the brain right here, this is what a normal brain looked like. This is the hippocampus on both sides that's missing in his brain. And after he came out of surgery, pretty soon after that, it started becoming clear to the doctors that something's not quite right. This is a different person. And so to study what is different in his brain now, the credit for that goes to this scientist, Brenda Milner, who worked with Henry for a number of years, studied what was different about him now. This was later taken over by her student, Suzanne Corkin, who then, as a result of their work together, wrote this book about Henry called Permanent Present Tense. And why this book is called that is because one of the fundamental things that was different in Henry's brain now is that after the surgery, he could only talk about or identify things in the here and now. He could not tell you what happened 5 minutes ago, who we talked to 5 minutes ago. It was just continuously, the brain was all about the here and now. This, a few decades later, they did an MRI when the technology became available. And here you see this part in the black with the asterisk. This is the part that was removed in the surgery, the hippocampus and some of the adjoining tissue. And this is part of the hippocampus that was still left in this arrow here. This is a quote by Brenda Milner, who's now 102 and still at the McGill University in Canada. where she says, I'm still nosy, curious. And this is kind of, why I like this is because this is kind of the reason why scientists do what they do, is because you're curious about things, how things work and what goes wrong when they don't work. So she's really inspiring in that sense. So let's talk about some of the work that they did at the time. So Henry was given a lot of tests to do and activities to do. And there is, so for example, one of the tests that he was given is what's called the face perception test. This involves showing the person images which are in black and white. Some of them have patterns of faces in it, and some are just black and white together. So the goal there is to identify, can the person identify which image has a face in it and not? And he was able to do that very successfully. So that told the scientist that his visual perception is fine. The problem is not in his vision. Then they did, this test is called stepping stone maze. So here you have this paper with all these dots on it, and you have to go from the starting point to the finishing point. And so for anyone, when this test is given, initially you make mistakes trying to figure out, but then once you figure out this is the path to take, subsequent trials, it will take you less and less number of trials to figure out from start to end. That's because as you figure out, each time you do, the hippocampus forms memories of remember how you did last time. So as a result of that, we get better with every trial we do. So in case of his brain, though, he did get better, but then he would not, actually in this test, he did not get better because he couldn't remember. His brain could not form memories of what did you miss last time and to get better. So he did that test a couple hundred times, and each time it would take him about the same number of trials. They gave him other tests as well, where one is where you have to draw, trace a drawing looking at the image of an object. And that was something that he got better at with time, but then he didn't have any memory of getting better. Yet for him, drawing that object every time was like drawing it the first time, even though he was getting better. He didn't remember getting better. So what does that tell us? Studying his brain tells us all of this was unknown at the time. It tells us that the brain has different systems for immediate and long-term memory. So he couldn't tell you what happened 5 minutes ago, but when he was shown pictures of famous people from the time before his surgery, he could identify those. After his surgery, not at all. So brain has different systems for immediate or short-term memory and long-term memory. This part of memory in his brain was intact. He just couldn't form any new memories. Then the test that they gave him told the scientist that because he could get better at, so there is things like, tying your shoelace or button your shirt, brushing your teeth, things we learn as kids, but then once we learn it, we can just do it without thinking about it. So that's called procedural memory. So learning to do something, what the procedure is in a sense. He had this, but then he couldn't, like I said, couldn't tell you that he got better or that he had practiced it, even though he got better. And this is the other system of memory is declarative memory. When we talk about memory in everyday language, this is what we mean: recalling facts, figures, information. This part in his brain was severely compromised. And because the part of the brain that was removed, even though a part was removed, the recalling of memories made earlier was intact. So that tells us that where the brain stores earlier memories is not the same site as the part that forms new memories. So all of this was really new information at the time, and we're still, what we have learned about memory since then is all built on top of what this one case study told us. There are other some notable cases in the history of neuroscience. One is this individual, Phineas Gage. He was a foreman. So he worked at a construction company, and his job was to pound out the dynamite, so before they would explode it. And one morning, as he was doing that, he was tampering the dynamite. It exploded prematurely. And so this rod here that he's holding, it went, so he was holding the rod and he was, tampering the dynamite. And when it blew, this entire rod went through his face from and into his brain. So this is a reconstruction of how that would have happened. It went into his cheek, behind his eye, severed his optic nerve, came out the top of his head. So this is, and taking with it a chunk of the brain itself, which is this black part right here. The entire rod, which is I think a couple of feet, the whole thing went through his head and landed a couple of feet behind him. Oddly enough, he survived the accident and he was alive for a long time after that. But what became clear was that shortly after the accident, there was a vast change in his personality. Before the accident, he was a mild-mannered guy, reliable employee, got along with everybody. And after that, he just became very irritable, got into fights, couldn't hold on his job, filthy language. So very stark change and brought about rather abruptly. So that tells us that what we call the seat of our personality is this part. It's in the forehead, the front of the brain right here, the part that's called prefrontal cortex. So one thing that is not discussed very widely about his case is that this change in personality was rather temporary. It lasted for a few years after the accident, but then eventually he kind of came back to how he used to be, which tells us that however traumatic the accident might be, the chance of the brain function restored are still very high. The next example is that of a person called Lazare Lelong. This was a person who, because of syphilis, lost part of function in one of his part of his brain. So this is because of that he could only utter one syllable. He could not produce any the language. So this is how we know that these are the language parts of the brain. In the blue and the yellow here, they're called Broca's areas for the physician who identified these areas. The third is a relatively recent case of a patient who's known as patient SM. She has a rare disorder because of which she has lost function of a very specific part of the brain. Let me see. So if you can see here where the arrows are pointed, never mind, I lost the arrows here, right here. These are the two black dots right here. This is the brain region called the amygdala. And because of her rare genetic disorder, she lost specifically these areas. So this is the amygdala on either side. And it is when you look at the whole brain, it's about at this level in the brain, so quite deep into the brain. This is the scan of a person for comparison who's lost amygdala on one side. So this is where the amygdala normally is. And in this person, it's gone on this side. But in the case of patient SM, she's missing the amygdala on both sides. So what does that do? And what does the amygdala do? So when researchers gave her tests to do, so this is part of, the amygdala is part of the emotional circuitry of the brain. So how did loss of the amygdala affect her? So she was given tests where she had to draw human face for different emotions. So she could draw practically everything else, happy face, sad face, angry face, and so on. But if you see here, what she has drawn for afraid, this woman has no concept of what fear looks like, what it feels like. So this is how we know that amygdala is big in doing fear, our response to fear that is mediated in large part by this part of the brain called amygdala. Another thing we learned through her case was that not only does the amygdala do fear, there's another function linked with fear, which is fear-induced memory. Something bad happens to you, not only are you afraid during the time it happened, your brain will then form memories of remember when that happened, don't do that again. She is completely lacking that. So there was an incident in her life where she walked through a park after dark, not much light around. She walked through the park. So first of all, we would have what somebody with the intact amygdala would have what's called anticipatory fear. You right, just to see that, you would look like, you know what, it doesn't look like right, don't go there. She didn't have that. She went walked through the park, somebody pulled a knife on her. Miraculously, she survived that, only to go back through the park again the next day. No fear-induced memories. She was completely lacking that. So there's many such cases where we have learned about, based on what has gone wrong, this particular symptoms people show, physicians and scientists were able to backtrack and figure out what is wrong. And that's, this is how we've identified a larger part of what we know about the brain. This is some of my favorite books, and in these two books also includes a lot of case studies. The Telltale Brain by V.S. Ramachandran and Tale of Dueling Neurosurgeons by Sam Keen. He includes some very historic examples, starting from Henry VIII to more recent examples of case histories that have informed us about what the brain does and how it does what it does. This book by David Eagleman is Brain, the Story of You, of how your brain shapes your life and how your life shapes your brain. This one is a personal account by neuroscientist Jill Bolte Taylor. She is she has a rare genetic disorder because of which she had a stroke when she was in her 30s. So this book is about the anatomic part of what happens to the brain during a stroke, but also her personal experience of having had a stroke. Her TED Talk is really worth watching, so I would highly recommend that. So at this point, so now let's switch gears from case studies to a little more about the different parts of the brain and how they're divided, how they each do what they do. So this particular model is called the Triune brain model, which says that in your head is not one brain, but three. One is the reptilian brain, the ancient brain. This part does your basic housekeeping functions of monitoring heart rate and blood glucose and body temperature and so on and so on. Things that we don't think about, but your brain just does. Then on top of that is the limbic system, or the emotional brain. And then on top of that is the new mammalian, or the cortex. This is where your rational thinking, decision making, planning, all that functions are up here. A lot of people don't like this model because they think it is too simplistic. I included that here because one, it tells us that different parts of the brain are of different emotional or evolutionary age. These are relatively ancient compared to this part right here. But in the normal course of our everyday lives, all these functions of these are aligned, so they each has their part cut out for them, so that we can, make our way through everyday life. But sometimes, every now and then, one of these parts will hijack controls and take over a function that is run by another part. So, for example, your heart beating faster when you get emotional. That's the limbic part running the brainstem, or the reptilian brain. Heartbeat is a function of the brainstem, but when you get emotional, it changes the function of the other part, the reptilian or the brainstem part of it. Also, when you see a movie and you get emotional, you either cry or get angry or experience any kind of emotions, that's because the cortex, the front of the brain, can do abstract, it can process abstract situations, and if that's something that arouses emotions, that is the cortex commanding then the emotional part to express emotions. Even though the thing is not real, you go through the emotions as if it is. And which also tells us something really interesting about the brain, is that it cannot distinguish between when something is actually happening versus when you're imagining it happen. We react pretty much the same way. So this is where we, now we looked at, layer 2 running layer 3, or layer 1 running layer 2, but the other way, reverse also happens. So for example, when we're hungry, blood glucose drops. This is the function now of the brainstem, what's called the reptilian brain. When that happens, we tend to be harsher towards others. It affects decision making. There have been many studies done about this in lab, in field, where people's decision making, people tend to be less likely to give other people benefit of the doubt, to give them a second chance, and more likely to be, or for giving them stern punishment when they're hungry. Another scenario is when we make stupid decisions when we're in an emotional state. Again, decision making is a function of the cortex. But when emotions are running the show, you tend to do things or say things that you otherwise wouldn't do if you were thinking rationally. So that here again is emotions hijacking the decision-making part, which is the function of the cortex. So at this point, let's talk a little bit about what's called the social brain. So in all social primates, including us, what is hardwired in our brain is the sense of us versus them. Who counts as an in-group member, who counts as an out-group member. We behave differently on who we consider as one of us and who's an outsider. And in this sense, one hormone is studied very widely called oxytocin. And what was thought about it is that, so this is a hormone that, enhances bonding between mother and child. So it was painted as this, this hero of our emotions, and enhances pro-social behaviors, until people dug deeper and found out it enhances pro-social behavior, but only towards those we perceive as us, our group. It makes you more antisocial, makes you more against the anyone you consider as one of the outgroup, one of them. But what's very interesting about humans is this distinction of us and them is very changeable. A very simple example is if you're watching cricket and, India versus Australia, and this Australian player takes a wicket, takes out one of your own, and no, you're mad at him now. How damn this guy. Few days later, his same guy, but wearing different shirts now, playing for Chennai Super Kings, and he does the same thing. And this time we're cheering for this guy. Oh yes, good job, buddy. Same guy. One day he was one of them. We didn't like this guy. Now he's one of us. It's that simple. It's so to make this switch of us versus them, it's just very easy for human beings. And that's the scary part of it, is that any ideologue can come along, and they do, and sort of polarize us towards anybody that they consider one of them. We don't like them. And the thing of it is that you don't have to know any neuroscience to polarize this, to introduce this us versus them thinking. In general, by our biology, anyone we consider not one of us, we don't like. So all you have to do is introduce this difference, and you will make people act mean towards others. But because of the fact that it is changeable who we count as one of us or not one of us, if we're aware that this is how our brain works, I'm hoping that if enough of us know the neuroscience behind it, that at least it can put a pause on this extremely polarization epidemic that we also have going on. So at this point, I want to talk a little bit about related to what we've been saying so far, the different parts of the brain and how they work differently. This is the subject of another Nobel Prize winning discovery, is a system of the brain and how it processes things. And this time the author, Richard Kahneman, he called it thinking fast and slow. So he describes that you have two systems in your brain. One is system one that decides fast, not necessarily correct, just fast. This is all our intuitions, gut feelings. Anytime we're acting on autopilot, this is the system that's running the show. System two is the logical thinking or reasoning, or this is the slow system. This is where you have to, for example, if you are asked to multiply 157 by 713, you have to recall the mathematical tables that you learned as a child, do the calculations, and figure out the answer. So when this system is in charge, you're focused on one task, the task at hand. When this is running the show, the point is to just make decisions fast. And so the idea, what he talks about here is for us to be aware that when we're making decisions, we like to think of ourselves as logical beings. We look at all the options and then make decisions. That's not always the case. Sometimes when this system is running the show, your brain just decides and serves a decision up to you. We don't, and it seems to us that it's something I decided, but it was not a decision made. It was a decision done for you. So if we're aware of that, it can help us slow down and sort of examine the reasoning behind. Another thing that the brain is very good at is after the fact justification. Once you have decided something, then it'll come up with very ingenious ways of telling you why that was the right decision to make. So in this thread, it's a very good time to talk about cognitive biases. We all have biases. That's just the natural outcome of when your brain does what it does. Biases, stereotypes, prejudice, it's just a natural product of that functioning. There is many kinds of biases. I have just some of the star examples here. One is called the anchoring bias. This is that whatever information that comes at you first, any information that comes after that is examined in relation to this information that came first. So this is used in negotiations, for example. So negotiators will start either really low or really high, because once you've given that one number, that will serve as an anchor for the brain. So the subsequent numbers that come will be something that is anchored in the first number you heard. It doesn't have to be that way, but that's brain's default machinery. And so you will, if somebody said 1,000, if you want to go low, you'll say 750 or 500, not 10, because your brain is anchored in the 1,000 that you heard first. The next one is called sunk cost fallacy. This is when it becomes clear to us that a decision that we had started on, even with the best of intentions, was a bad idea, shouldn't have done. But once we have committed to it, we just continue with it, even when it makes logical sense to abandon it, cut our losses, move on in a different direction. We still stick with it, continue watching the bad movie we don't like, a bad restaurant meal, whatever it is, because we think, I've already invested so much in it, I might as well continue, when it makes no logical sense to do that. But by far the most damning, the most pervasive is this one called the confirmation bias. This is once the brain has decided something, it will look for evidence only one that agrees with what it has already decided. So this is a large part of why, despite our best intentions, even fake news can go viral, because it may appeal to a bias that you already know. You may not be aware that you hold this bias, but something comes along, something crosses your path, comes in your phone that you agree with. You may not know why you agree with it, but it's something sounds like, this is something I would agree. It agrees with the bias you already hold. This is confirmation bias. Now, when you combine that with after the fact justification, this makes for a deadly cocktail. This is why we don't take it kindly to when somebody confronts us. Anytime you've confronted anybody with what they're thinking is wrong, you hardly ever see, somebody going, oh, yeah, I was wrong. No, they will dig in deeper. They'll give you other things, because their brain is coming up with things of why what I thought is the right thing to think about. And it's very hard for us to accept when we made a mistake. So all of these cocktails go into making of that framing of that mental framework. So this cartoon, in my opinion, sums it up really well. When you get something, an information that contradicts with something your brain has already decided, we're receiving information that conflicts with the core belief system. Here you have built as a mafia boss, get rid of it. It doesn't take, if it's a memory previously formed, it gets rid of it. If it's an evidence coming now, it ignores it. It only looks at things. Now, why would it do that? Because it counts for easy or quick decision making. Brain, if you look at it from evolution point of view, it makes sense for decisions to be made fast. If you made a wrong decision, well, okay, you live and learn. That's why, that's the same. But then if you took a long time to decide something and now your life is in mortal danger, that's not so good. So evolution has primed the brain for making fast decisions. they're not always right decisions. I want to now go through a couple examples of, where brain, once it gets what I was just talking about, when it gets conflicting information, what it does with it. So this is a effect called McGurk effect. So here, this is a test given to volunteers, and what you do here is, what you see with the image on the left is that the volunteers will watch somebody say the word ba. So just over and over, he just keeps saying ba, ba, ba. And so they hear the audio of ba and they see the person saying ba. So then you ask them, well, what did you hear? And they'll say, well, I heard ba. Great. Now for the next step, the audio that plays is still saying ba, but the video that is shown to people is a different sound. In this case, the researcher is making the sound of ba. So here they put together a visual of ba with the audio of ba. So now your brain is conflicted. What it sees and what it hears, it's telling is different things. So in this case, it will suppress one and go with the other. For most of the time, the brain trusts visual more than auditory. So in this case now, when you ask people, what did you hear? They'll report saying ba, even though the audio played was ba. And the only way in this situation is to actually hear ba is to close your eyes. And then you're able to hear the same audio track, and now you hear it correctly. So this goes to show you that even when it comes to physical sensations, we're not even talking about heavyweight stuff or your views and opinions on a particular topic, but even sensory information, when it gets conflicting information, it suppresses one, goes with the other. Similarly here, in this example, if I ask you to look at the symbol in the middle, you'll be either seeing it as the number 13 or the letter B, depending on whether you're really reading it vertically or horizontally, okay? And so here, similar to what you see in McGurk effect, even when you know this is, it can be this and that, at one time you'll be able to see it either as B or as 13. Goes again to show when the brain gets conflicting information, it chooses one, suppresses the other. We don't know a lot about how it, makes the decision of which to go with. So that makes it kind of a fascinating, but also incredibly dangerous. Your brain is just making decisions for you, in a sense. So now I want to switch gears and talk about some of the recent technologies in neuroscience and how we study the brain. So this technology is out only 6 or 7 years ago. This is to where we can grow parts of the brain in lab in a dish. And this is very exciting to do for human brain because, well, for obvious reasons, when studying diseases or even development, what happens you don't have, unless you have autopsy tissue, you don't know what is happening in actually in human brain. So this technology, even though it's very new, it's very widely adapted, including in our lab, because of what is possible to study with this. So let's look at a few examples. So here, this is using the system called mini brains or organoids. It's called organoid because it's not quite the organ, the brain, it's sort of like an organ, hence the word organoid. So here we see mini brains or cerebral organoids being used in the study of microcephaly. This is a condition where a child has a smaller head than what should be for his or her age. So this is a child, this is the normal brain size at birth. This is the MRI. And here is a child with microcephaly. So you can see it's a visibly smaller head. And what you see in the MRI here is that the folds that are characteristic of our brain, you see less of those. So the folds that are normally, that should be there in the human brain, you see less of that. So why does that happen? Well, when people studied that using the organoids, this is what they found. So here, if you see this image, this red band that you see right through here, this is a zone of cells. These are called neural precursors or progenitors. The job of these cells is to just divide and divide and divide. And these are the cells that ultimately form neurons in the brain. which is in the green right here. So in someone with microcephaly, this entire region is only this long. So the starting pool of cells that make up cells of the brain is much smaller, and therefore you get smaller number of neurons, and therefore you get smaller head. Now, on a different disease, schizophrenia, or what is also called thought disorder. This is one of the diseases we study in our lab. This data is from a different lab though. So here they have studied what happens in the, so organoids, because they model the early development of the brain, we're able to see now what's happened in the brain of a person who has schizophrenia, which otherwise you cannot study because the symptoms don't even become evident until somebody is in their late teens or early 20s. This has been thought for a long time that the roots of mental illness, even though the disease manifests later in life, the beginnings of that happened much early, but we had no way of studying that because, well, specifically for schizophrenia, there are no animal models, no animals experience schizophrenia. So we have no way of knowing what happens early on for somebody to then develop schizophrenia later in life. So here what these scientists had done is that they have taken cells from you either take skin cells or blood cells, and then you reprogram them. You essentially turn the time clock on these cells back to the point where it was how the brain starts to form, the image I showed you earlier of the neural tube, and then how progenitors divide from there on. So once you do that, you find that, so this is what happened normally. So this is your layer of neural precursors. These are the cells divide and in a very orderly fashion move up and out, and then form the neuron layer here. Well, for somebody who has schizophrenia, their brain, what would happen? So what the organoid tells us is that the population, the number of these cells, precursor cells, is much less. Not only that, they're not distributed in this orderly fashion like you see here, but they're kind of haphazard all over the place. So once these precursors are moving rather randomly, the neurons, when they form, their connections are also not going to be normal, which is what we learned from this that we did not know before. Finally, to talk about COVID, because this technology again has been helpful here. So quite a few people with COVID experience neurological symptoms. So there the question becomes, what's happening? How is the virus getting into the brain? Well, the organoid research tells us, yes, it is. That this virus can affect the cells of the brain. So if you take an organoid, which otherwise looks like this, now, and you put the virus on them, wherever you see green, that's the virus. That's the virus infected, that has infected the organoid cells. So that tells us that the virus is able to get into cells of the brain directly. We don't know clearly how it gets there. Is it a direct function, or is it once the inflammation is severe enough, then it's the secondary outcome of that? That is not quite clear. But this much, at least from the organoid, we can tell is that the virus is able to get into the brain cell, which can explain the neurologic symptoms that many patients experience. So I want to close with, 1 second though, my battery is kind of running low, 1 second. Much better. So now I just want to close with talking about the project that I'm part of at NIMHANS called the Adbs Project. So here we're looking at mental illnesses that runs in families. So this is a hypothetical example of a family tree. In the black that you see, these are the cases, and then you have unaffected members in the family that do not have any illness. So what we do is we collect blood cells from the patients as well as their relatives that do not have any symptoms after they agree to participate in the study, of course. And then some of the cells, we do the same thing. We reprogram the blood cells into becoming pluripotent cells, and then the cells of the brain. And then the other thing we do is we look at their DNA of the people who have symptoms versus who don't. The idea there being that because the illness runs in families, there may be genetic clues to people who have symptoms versus who don't, and are we able to identify those clues? So we will have actually a paper coming out in the next few weeks, looking at all these, so piecing information together from all of these about bipolar disorder. I want to now close with just one quote with Henry Molaison, or patient HM, the person because of whom we know a lot about the hippocampus. He said here, Henry is talking about his neurosurgeon, saying that what he learned about me helped others, and I'm glad about that. So I wanted to say that here, for all the patients and their families who agree to participate in our study, knowing full well that very likely they will not receive any immediate benefit from it, but because they still agree to participate anyway, we learn a lot about the brain and what goes wrong in diseases, and hopefully using that information can lead to benefits for later treatment. These are some links that I thought could be helpful. Brain Facts, this is a website maintained by the Society for Neuroscience. It's a fantastic resource for just even if you want to learn the basics of the brain, the different parts, what they do, but also information on different disorders, Alzheimer's disease, Parkinson's disease, and so on. This is something I would highly recommend. It's called the implicit association test. It is to figure out what biases you have, because otherwise, like I said, even though a lot of us know that we have biases, it's hard for us to accept, or like I have gotten, people will outright say, I don't have any biases. I'm not a biased person, but I would recommend please try it out and you'll be in for a surprise. This is a website called Illusions Index, visual and otherwise illusions. So this is where example of just the brain in its processing, it tries to help, but then it sometimes results in very weird perceptions. So this is one example. It's a GIF, and you can see it on the website. This is, so you have this pylon here and here, and what you see is they're skipping like kids with the skipping rope. They have the wires that are skipping. And what you see is this one in the middle is jumping like a kid would do when kids are playing skipping rope. So why this is interesting is that some people, when they watch this, they hear a sort of metal sound when these wires hit the ground. They hear a sound, even though the GIF itself is mute. There is no sound with it. So a lot of people actually hear sound. So this is when you expect a sound to be there, your brain, because it expects it, you hear it, even though it's not actually there. Hidden Brain is an excellent podcast looking at real life ramifications of brain functions. And finally, this is a TED talk by one of my favorite neuroscientists, Robert Sapolsky, called Biology of Our Best and Worst Selves. So here among the examples he gives is how the default network, the default thinking of the biases and stereotypes, and how they can shape our actions in the current path in our everyday life. So that is that. And since we started with one game, I thought I would close with another.
You have to switch over the window.
Can you see?
No, I'm not seeing it. No, you have to switch over the window.
You're not able to see?
Yeah, it's showing in another window. You have to share that window instead of that.
One second.
Yeah.
Okay, here we go. Now?
No, yeah, now it's.
Okay.
Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla? This video is from research by Daniel Simons and Christopher Chabris and is copyrighted.
Okay, so that's about it from me, and I am happy to take any questions. Thank you.
Thank you very much. I think Vijayan will coordinate the question.
Before we switch on to the question answer session, let us have a brief brief on Tamil by Mr. Salakumar.
வணக்கம் சார். வணக்கம். அறிவியல் தமிழ்நாடு அறிவியல் இயக்கத்தின் 32வது பரப்புரை கூட்டத்திற்கு வந்திருக்கிற அனைவரையும் வரவேற்கிறேன். வணக்கம். அதாவது அம்மையார் பேச்சாளர் அற்புதமாக ஒரு உரையாற்றினார். அதாவது நீ உன் மூளை என்பதிலிருந்து உனக்கும் உன் மூளைக்கும் இதற்கு சம்பந்தமான இந்த தொடர்பான விஷயங்களை அற்புதமாக எடுத்துக்கொள்ளினார். அதாவது அவருடைய ஆரம்பங்கள் 2004 நோபல் பரிசு பெற்ற அந்த கண்டுபிடிப்பிலிருந்து வந்து ஆரம்பித்திருக்கிறார். அதாவது ரிச்சர்ட் ஆக்சல் மற்றும் லிண்டா அவர்கள் வாசனை உணர்வு ஏற்பியை கண்டுபிடித்ததற்காகவும் வாசனை மூளைக்கு கொண்டு செல்கின்ற அந்த ஆல்ஃபாக்டிவ் அமைப்பில் அதன் செயல்பாடு எப்படி இருக்கின்றது என்பதை தெளிவுபடுத்தியதற்காகவும் அந்த நோபல் பரிசு அவருக்கு கிடைத்தது. அதாவது இந்த உரையின் ஆரம்பமே இதிலிருந்து ஆரம்பிக்கிறது. அதாவது மூளை அந்த வாசனை உணர்வை எப்படி எடுத்துக்கொள்கிறது என்பதை இந்த பகுதியில், அடுத்ததாக இதே நோபல் பரிசை இதே மாதிரியான நோபல் பரிசு 2014 3 பேருக்கு கிடைத்திருக்கிறது. அதாவது அதில் என்ன முக்கியமான என்னவென்றால் பிளேஸ் செல்ஸ் மற்றும் கிரிட் செல்ஸ் என்ன என்பதை பற்றி அந்த நோபல் பரிசுக்கான அந்த குறிப்பில் இருக்கிறது. அதாவது ஜான் ஓகீஃப், அதாவது 1971 ஹிப்போகாம்பஸ் என்ற அந்த மூளையில் உள்ள ஹிப்போகாம்பஸ் பகுதியில் ஒரு விதமான நரம்பு செல்லை கண்டுபிடித்திருக்கிறார். அதுக்கு தான் பிளேஸ் செல். அதாவது இந்த பிளேஸ் செல்ஸ் என்பது பொதுவாக மேப்பிங் சிஸ்டத்தை, அதாவது பார்த்தீங்கன்னா கரெக்டாக சொல்றதா இருந்தால் நம்ம இப்போ ஜிபிஎஸ் அப்படிங்கிற ஒரு இதை நம்ம செல்போன் தொலைபேசியெல்லாம் பார்க்குறோம். பட் அதே போன்ற ஒரு அமைப்பு நமது மூளையிலும் இருக்கிறது. அதை வந்து இன்னர் ஜிபிஎஸ் அப்படின்னு சொல்லுவோம். அதாவது கரெக்டாக அவங்களுடைய மெடிக்கல் சரியான மருத்துவ வழக்கில் சொல்வதான பொசிஷனிங் சிஸ்டம் என்பது. இந்த பொசிஷனிங் சிஸ்டம் வந்து பொதுவாக இது 2 வித, அதாவது ஒரு சோதனை சாலையில் உள்ள ஒரு எலியின் மூலமாக கண்டுபிடிக்கப்பட்ட இந்த ஆய்வு அறிக்கை. இது 2 விதமான செல், அதாவது பிளேஸ் செல்ஸ் ஒன்றும் மற்றொன்றாக மேப்ரிட் மற்றும் எட்வர்ட் மேக்சர் இவங்க வந்து கிரிட் செல்ஸ் இந்த வகையான செல்லை அவங்க கண்டுபிடித்திருக்கிறார்கள். இது என்ன விஷயம் அப்படின்னா, பொதுவாக அதாவது நமது சுற்றுப்புற சூழலை ஒரு வரைபடமாக மாற்றி நமது இருப்பு, நாம் எங்க போகணும் எங்க வரணும் அப்படிங்கிறத நம்ம நகரக்கூடிய பாதை முறைகளை இந்த செல்கள் நமக்கு கரெக்டா ஒரு பாதை வகுத்து நம்மை அறிய செய்கின்றது. இதுதான் முக்கியமான விஷயம், இந்த 2 கண்டுபிடிப்புகளை. இதுல முக்கியமா என்ன அப்படின்னா, இந்த ஹிப்போகாம்பஸ் அந்த செல்லை பற்றி ஏற்கனவே 1950களில் மில்லர் என்பவர் ஏற்கனவே அவருடைய சக மாணவர்களுடன் சேர்ந்து ஒரு ஆராய்ச்சி மேற்கொண்டிருக்கிறார். இதுல என்ன அப்படின்னா, வலிப்பு நோயின் காரணமாக வந்த ஒரு நோயாளியின் மூளையில ஹிப்போகாம்பஸ் உட்பட அந்த மீடியல் டெம்பரல் லோப் பகுதி நீக்க வேண்டிய கட்டாயம் ஏற்படுகிறது. இதன் விளைவு என்ன அப்படின்னா, அவர் அன்றாட செயல்களை ஞாபகம் வைத்துக் கொள்வதில் ஒரு பெரிய பிரச்சனை வருது சுத்தமா. இதுல என்ன அப்படின்னா, அது சம்பந்தமா நிறைய ஆராய்ச்சிகளை செய்யறாங்க. அதுல ஆராய்ச்சி முடிவுல என்ன வருது அப்படின்னா, இதன் மூலமாக அவருடைய ஷார்ட் டர்ம் மெமரி லாஸ் வந்து அவரால் ஞாபகப்படுத்த முடியல. ஒரு விஷயத்தை செஞ்சா திருப்பி அதையே செய்ய வேண்டிய ஒரு கட்டாயமா இருக்கு. அவருக்கு அது ஞாபகம் சுத்தமா மறந்து போறது. அந்த மாதிரியான ஒரு குறைபாடு அவருக்கு இதனால் இந்த ஆபரேஷனால அதுக்கப்புறம் வருது. இது அதுக்கப்புறமாக இந்த இதுல என்ன அப்படின்னா டிக்ளரேட்டிவ் மெமரி, அந்த ப்ரொசீஜரல் மெமரி அப்படிங்கிற 2 விதமான ஒரு இதை அவங்க வந்து கண்டுபிடிக்கிறாங்க. டிக்ளரேட்டிவ் மெமரி அப்படின்னா அந்த காரணங்களை ஆராய்வது, அது சம்பந்தமான ஒரு ஞாபக சக்தி முறை, அது ஒண்ணு. அதுக்கப்புறம் ப்ரொசீஜரல் மெமரி, அதாவது படிப்பினைகள் மூலம் வரும் ஒரு ஞாபக சக்தி. இது எல்லாமே எந்த அளவுக்கு இதனால பாதிக்கிறது அப்படிங்கறது அதை ஆராயறாங்க. இதுல என்ன விஷயம் அப்படின்னா, பொதுவாக அவங்க வகைப்படுத்தும் போது ஒரு ஒரு இன்னொரு கேஸ்ல, அதாவது அடுத்தமான கேஸ்ல ஒரு விபத்துனால ஒரு மூளை பகுதியில் ஒருத்தர் பாதிக்கப்படும் பொழுது அவருடைய ஆளுமை தன்மை எந்த அளவிற்கு பாதிக்கிறது, அதாவது பர்சனாலிட்டி சேஞ்சஸ் எந்த அளவிற்கு பாதிக்கிறது என்பதையும் இது சம்பந்தமான அந்த அடுத்த ஒரு ஆராய்ச்சி. இது போக இரண்டாவது ஒரு கேஸ், அதுல பல்வேறு படிப்பினைகள் மூலம் பல பய உணர்வை சுத்தமாக மறந்து போகுது. அதாவது இது என்ன அப்படின்னா, ஏற்கனவே அவர் ஒரு செயலை செய்து ஒரு பயந்து போயிருந்தாலும் திருப்பியும் அந்த செயலை வந்து அவர் செய்வதற்கு எந்தவித தயக்கமும் காட்டுவதில்லை. அந்த மாதிரியான ஒரு படிப்பினை. அது போக மூன்றாவது ஒரு கேஸ்ல வந்து என்ன படித்துக் கொண்டார்கள் என்றால் ஜெனடிக் டிசார்டர், அதாவது மரபணு குறைபாடு. இந்த மரபணு குறைபாடு எப்படி வருகிறது, இந்த மாதிரியான சூழல் எப்படி வருகிறது என்பதை பற்றியும் அதை விரிவாக சொல்லியிருந்தார்கள். அடுத்ததாக 3 வகையான பிரெயின் ப்ராசஸிங் மெத்தட், அதாவது டெவலப்மெண்ட் ஆஃப் பிரெயின் என்கிற ஒரு பிரெயின் வளர்ச்சி, மூளையின் வளர்ச்சி பற்றி 3 விதமான மூளையின் வளர்ச்சியை பற்றி அவர்கள் கூறியிருந்தார்கள். இந்த 3 வித மூளை வளர்ச்சி கோட்பாடு ட்ரூயின் பிரெயின் அப்படின்னு சொல்லுவாங்க. பொதுவாக நியூனோ மெமாலியன், வழக்கமாக ருட்டீனாக நம்ம செய்கிற வேலைகளை செய்கின்ற ஒரு மூளையின் ஒரு பகுதி. அப்புறம் பாலியோ மெமாலியன், அதாவது எமோஷனல், அதாவது உணர்ச்சிகரமான சில விஷயங்களை செய்யக்கூடிய அது சம்பந்தமான மூளையின் ஒரு பகுதி. அப்புறம் கார்டெக்ஸ், டிசிஷன் மேக்கிங், அது முடிவெடுக்கும் திறனை கரெக்டாக முடிவெடுக்கும் திறனை செய்யக்கூடிய மூளையின் ஒரு பகுதி ரெப்டிலியன். இந்த 3 பகுதியை பற்றி ஒரு கோட்பாடுகள் சொல்லியிருந்தார்கள். இதில் ஒரு சிறு அடுத்ததாக இது என்ன அப்படின்னா, இந்த 3 பகுதிகளிலும் நிறைய வந்து சில நேரங்களில் முரண்பாடுகள் இருக்குது. ஒரு பகுதியோட செயல்பாடு இன்னொரு பகுதி அதை எடுத்துக்கொள்வது, இதில் ஓவர்டேக் சொல்லுவோம் இல்லையா, அந்த ஓவர்டேக் செய்து கொள்வது அப்படிங்கிற நிறைய முரண்பாடான சில விஷயங்களும் இந்த இடத்துல நடக்குது. பொதுவாக பார்த்தோம்னா, நம்ம பசியோடு இருக்கும் பொழுது சில நேரங்களில் சற்று மூர்க்கத்தனமாக நடந்து கொள்வது, அதே மாதிரி மூர்க்கத்தனமாக நடந்து கொள்ளும் போது, அதாவது சில கொஞ்சம் எமோஷனல், அதாவது உணர்ச்சிகரமாக வேளையிலே சில முட்டாள்தனமான இல்லை எதிர்மறையான ஒரு முடிவுகளை எடுப்பது. இது எல்லாமே அதாவது ஒரு செயல்களை செய்யும் போது அது வேறு வித மூளையினுடைய வேறு பகுதிகள் செய்ய வேண்டிய சில வேலைகளும் இது செய்கிறது. அந்த மாதிரியான சில ஒரு செயலை ஓவர்டேக் செய்து இன்னொரு பகுதி அதை செய்வது, அந்த மாதிரியான செயல்கள் இது செய்கிறது. இது போக சோசியல் பிரெயின் அப்படின்னு அவங்க சொல்லுவாங்க. அதாவது சமூகத்தை இந்த மூளை பார்க்கின்ற விதம் அப்படிங்கிற மாதிரி நம்ம எடுத்துக்கொள்ளலாம். அதாவது சோசியல் பிரெயின், அதாவது நாம் இல்ல நம்முடைய அஸ் வைஸ் தம், நாம் மற்றும் அவர்கள் அப்படிங்கிற மாதிரி, நாம் நம்முடைய அல்லது அவர்களுடைய அப்படிங்கிற மாதிரி எடுத்துக்கொள்ளலாம். இந்த விதமான பார்வையில் மூளையின் செயல்பாடு எப்படி என்பதை அருமையாக குறித்து சொன்னார்கள். இது போக இன்னொரு நோபல் பரிசை பற்றியும் கோன்மேன் என்கிறவர் திங்க் ஃபாஸ்ட் அண்ட் ஸ்லோ, இதை பற்றி ஒரு கோட்பாடை அற்புதமாக கூறியிருந்தார்கள். இதில் மூளை வேகமாகவும் இன்னொரு வகையிலே மெதுவாக என்பது சொன்னால் பொதுவாக அந்த காரண காரியங்களை ஆராய்தல், ரீசன், அந்த மாதிரியான சில விஷயங்களில் மூளை மிகவும் மெதுவாக செயல்படுவதை குறித்து அற்புதமாக விளக்கி கூறினார்கள். இது போக காக்னிட்டிவ் பயாசஸ், அதாவது அறிவார்ந்த நடுநிலையிலிருந்து தவறுவது அப்படிங்கிற மாதிரி, அது 3 விதமான அந்த பயாசஸ், 3 விதமான செயல்பாடுகள் இதுல இருக்கிறது. அதாவது முதலாவதாக ஆங்கரிங் பயாசஸ் இந்த மாதிரி, அதுக்கப்புறம் சங்க் காஸ்ட் ஃபேலசி, மூன்றாவதாக கன்ஃபர்மேஷன் பயசஸ். இந்த 3 வகையான காக்னிட்டிவ் பயசஸ் இருப்பதாக அற்புதமாக கூறினார்கள். அதாவது அடுத்ததாக ஏற்கனவே உள்ளதை மறைத்து வேறு விதமான அவர்கள் சொன்னதே திருப்பி சொல்ல வைப்பது, அதாவது மெக்ரான் எஃபெக்ட் அப்படின்னு சொன்னாங்க. மெக்கோர்க் எஃபெக்ட். இது வந்து ஏற்கனவே உள்ளதை மறைத்து வேறு விதமாக அந்த ஒரு அப்படிங்கிற ஒரு ப்ரொனன்சியேஷனை ஒருத்தரை சொல்ல வச்சு ஒரு படம் காமிச்சாங்களே, அதே தான். ஏற்கனவே ஒருத்தர் அது இருந்தாலுமே அதை வந்து இவங்க சொன்னதே திருப்பி சொல்ற மாதிரியான ஒரு செயல்பாட்டு முறை. இதுதான் மெக்கோர்க் எஃபெக்ட். அடுத்ததாக லேப் க்ரோன் மினி பிரைன்ஸ். இந்த மினி பிரைன் வந்து எதனால ஏற்கனவே இருக்க அதாவது சாதாரண ஒரு மனித மூளையை விட ஏற்கனவே மினி பிரைன் எதனால் சிறியதாக இருக்கிறது, குறிப்பாக நியூரான் வளர்ச்சி குறைவது எப்படி என்பதையும் விளக்கிய அற்புதமாக கூறினார்கள். இதெல்லாம் போக இப்பொழுது நடைமுறையில் நாம் எல்லோரும் பயப்பட்டு கொண்டிருக்கிற COVID-19 வைரஸ், இந்த வைரஸ் மூளையை தாக்கும் விதம், அதனால் இந்த அதனால் இந்த மூளையில் ஏற்படுகின்ற பாதிப்பு, அதை பற்றியும் அற்புதமாக சொன்னார்கள். இது போக மரபணு நோய்கள், DNA சம்பந்தப்பட்ட அந்த நோய்கள், இதை பற்றியும் அற்புதமாக அம்மையார் விளக்கி கூறினார்கள். இன்னொருமாக கடைசியாக அற்புதமான இன்னொரு விஷயம், அந்த கடைசியில் அந்த விளையாட்டு ஒரு பால் வந்து எல்லாருமே ஒருத்தர் பாஸ் பண்ணி விளையாடுறது, அந்த மனிதன் அதாவது நாம் எப்படி அதை கண்காணிக்கிறோம், எப்படி கவனிக்கிறோம்ங்கிறத பத்தி ஒரு அற்புதமாக எடுத்து கூறினார்கள். இது அதாவது மனித மூளை விஷயங்களை எந்த அளவில் அது ஒரு தவறான விஷயங்களாக இருந்தாலும் சரி, அதை மனித மூளை எவ்வாறு புரிந்து கொள்கிறது என்பதை அற்புதமான வகையிலே ஒரு ஆராய்ச்சி செய்து கொண்டிருக்க அற்புதமான வகையிலே நமக்கு எடுத்து கூறினார்கள். அவர்களுக்கு நன்றி, வணக்கம்.
Thank you, Sellakumar. Excellent briefing. Before we go to the question answer session, so we have almost 30 minutes for question answer session. A lot of questions are lined up. Before that, I have one announcement. I request all the participants to fill up the feedback forms. We have provided the link in the chat box. Just click the link and fill up the feedback form. The feedback form are essential and it is helping us to improve our activities. Please fill up the feedback form. So let me start the question answer session. We have lined up a lot of questions and how we can proceed. Now, my suggestion is let me read the question one after another, and some people want to have direct interactions. Now I will give chances to the people who want to have the direct interaction. They have to raise the hand one after another, but I will have combine both the reading the question and as well as the asking the participant to ask the question directly. So let me start with that. Let me start with my first question. My question is on the McGrath effect. So there are two questions associated with this. One is it related to the is it the effect of the, some people I have seen that the stammering speech, is it something related to the McGrath effect? And I want to know about the mechanism behind the McGrath. Which part of the brain is not functioning when you have the McGrath effect?
So the effect has to do with how the brain processes conflicting information. That's what the effect is. McGurk was the guy who identified this, that when you have two routes of sensory information coming in and one of them is giving a different information than the other, the brain, how does the brain decide? So through studying this, we know that the brain will choose one option versus the other. So in this case, when you have different information coming in, your eyes are telling you something different than your ears, your brain will choose, and generally it will favor the eyes. It will trust what it sees more than what it hears. So not related to stammering at all. It just tells us how the brain processes information.
Okay. The first question is from Niveda Sundar. Can this confirmation bias be reason why it is very difficult to change this stigma or irrational views of the people which are closely tied to their religious belief?
Very also, yeah. So because there are so many kinds of biases, which biases involved in people not changing their minds it can vary, and it's not limited to religion only. Confirmation bias is once your brain has made a decision, has reached a decision, it will look at information only that agrees with this. It may really be related to religion, it may not be related it may be any topic at all, actually. Your opinion about somebody, I don't like that person, or what we think of people with certain last name, people who grew up in a particular state, people who are who speak a certain language, or whatever. Like the criteria can change, but because your brain is trying to decide something fast. How do you feel? Are you safe? That survival is the name of the game. It's not geared for today's extremely polarized, lot of information coming at you. It's almost like we're not built for that. So it's a liability, but we can get past it if we learn to question ourselves. Be open to the possibility that there could be other views aside from what you think. Be open to, are there other pieces of evidence that show the opposite of what I believe, or show something different than what I believe. Be open to different possibilities. Look at evidence, is what I would say.
The next question is from PK Rajan. Am I total slave of the pre-wired part of my brain? What's your opinion about the meditation, which is claimed to be giving some practice to control the brain processes?
Excellent question. So yeah, the good news is that no, we're not destined to live our lives slave to the functioning of the way the brain works, but we do have the option of not going with it. Realize that this is something that your brain has decided. Is it the right decision for you? Is what we have to go by. Be the owner of the brain, not let the brain own you. As far as the question on meditation, so I have not looked at the evidence very closely, but there are studies to show that they have done imaging of people who meditate for a while, and that their brain is physically different. Meditation changes the brain. So while I have not looked at it, I mean, logically, it makes sense. How you live your life changes your brain physically. Education changes the brain. If you are a person who tends to get stressed very easily or tends to stay stressed a lot, your brain will be physically different from someone who is not that way. So it makes sense that meditation it changes the way the brain works.
The next question is from Munati. Mini brains actually meaning is what?
Mini brain, as in it's a brain in a miniaturized form. You have the part of, like I went through part of it in the slides just now of the different parts of the brain. So you have a miniaturized version in a lab dish. That's why it's called mini brain. You have different parts, but it's not the whole thing. You have a slice of it, but it is how it would be. Whoever's cells you have growing in that dish, it would be, the cells follow the same path like they do in the fetus, which is why it's a valuable system to study.
Next question is from Aditya Verma. Why so much redundancy in brain?
Redundancy? I didn't follow. In what sense?
I don't know. Why so much redundancy in the brain? I don't know.
Maybe he can type what specifically he means by it. I'm not clear.
I'm not. No, we have to ask the clarification from the questioner. Aditya Verma, are you there? So we can switch on your mic. No.
Yeah, can we allow some of the hand raisers?
Okay. Hand raisers, where they are, I am not able to see them. Hand raisers.
Yeah, Ramaswamy, B. Ramaswamy.
Yeah. Just yeah. I see.
So, sir, what happens when we sleep? The brain also sleeps completely, or it works? We don't understand that. And second question is that something seizure. When seizure happens, it's also like sleeping.
No, so different things happen during sleep and during seizures. So when we go to sleep, different parts of the brain do different things. Your conscious they're the not conscious, the front of the part, the thinking, planning part, that rests. But then there are other parts of the brain that are more active at night than they are during the day. So different parts of the brain do different things. While we're sleeping, the brain does memory consolidation, sort of rehashing things, what happened in the day, which memory to store, which to keep. We don't know how it makes that decision, but all of these things, housekeeping, removing the waste and that surrounds the cells, all of that happens during the sleep, which is why it's very important to get a full good night's sleep. A seizure is uncontrolled activity of either part of the brain or the entire brain. So brain, the cells talk to each other via electricity. So when that electrical signal is uncontrolled, the symptoms would look different depending on whether it's the seizure, the electrical activity is confined to one part of the brain or it's the entire brain, but it's a temporary increase in activity, electrical activity in the brain.
Thank you, madam. Very brainstorming. Thank you.
Let me jump back to the questions. Now we'll come back to the hand raiser again. This is a question from Deepika. How the cognitive bias survived the test of evolution if they did not help in surviving better? Similarly, how do we justify ego offering survival advantage?
So there is nothing to say that the cognitive bias don't help us survive. If anything, they do, because it helps proceed. Bias is any kind of bias. It helps the brain to decide fast. If you decide fast, there is a chance you live through a dangerous or a potentially dangerous situation. There, if you take time to now decide, is this a stick or is it a snake? And should I go closer and see or whatever? If it's a snake, you're dead. So biases do help us in that sense because it helps for the brain to decide fast. Why it's a liability now is that a lot of times fast decisions are not the right decisions. For our ancestors who still lived, surrounded by the elements, for them, bias, as in getting to a decision fast, was very, very important. We don't face the same dangers and certainly not the same way, but because that machinery, the system of deciding quickly is still there, it can become a liability. You can decide about somebody, you don't like them, hardly knowing anything about them. It's not a logical way, but it's a fast decision that your brain made. What was the next question about ego? So
similarly, how we justify ego offering survival advantage?
So ego, that's a tough one to answer because there's not much neuroscience there. It's more a question for psychologists. Okay. So there is a thing of, what I can say is that there is this thing of my decision. We have the sense of whatever decisions we reach, it's my decision. I have consciously decided that. And to that sense, I will refer you to Dan Ariely, Ariely. He's a scientist and he's done a lot of studies to highlight just that, of how much of decisions we think we have made are our decisions, conscious decisions, and how much of it is just the brain deciding, just reaching a conclusion, serving up the decision to you, and you just pick that thinking it's yours. So there are advantages to processing information that way. It makes for quick decisions, move on fast, and at a certain point in human history, there was a survival advantage for that. Now we live in a different time. So it's a good practice, I think, in our daily life to sort of put the brakes on this, to say how much of this, what I think is really my decision, and how much of it my brain has just absorbed from our culture, from what I've heard from other people, reading something or whatever, and how much of it is just decision based on hearsay, and how much of it's actually my conscious decision.
Yeah, Reeteka, I would like to ask one. Yeah,
sure.
So I would really like to know, human beings, Homo sapiens sapien, have been for 250,000 years now. So if you say like confirmation bias would have been more of a social living. During the social living together, I'm not able to see how confirmation biases would have been advantageous. When you say that, okay, individually, I have to take an action, immediate reaction, and suddenly I came across something. And so, I understand, because, suddenly a snake comes and immediately I act. But when I come to social living, when we're living together, I somehow am not able to understand how these biases would have, because it really creates a problem between people.
The confirmation bias is the basis of all the decisions. There is many kinds of biases when it comes to
various biases. Various biases.
Aspects have different biases. So there, it's more the group thinking bias that we go by. If other people are thinking it, so again, if you think from the point of view of ancestors, human beings, we don't have, there is no claws, no sharp teeth. How do we protect ourselves? Our group, our community is our protection. So there, if you see everybody doing something, you did that even though you didn't understand, because that was the protection. So when it comes to social thinking, it's more of a group thinking bias that we go by. If other people are doing it, it must be the correct decision. Even though if I were to individually decide that, I may not do that. But I will be tempted to follow the crowd just because we think group thinking is the right thinking. So that's a different bias that operates there.
Yeah, I get your point. And is it that possible that during evolution, evolution has happened basically through mutations? So quite many mutations would have come. Some survived, some didn't survive at all. But some survived even though they were not, they just came along with some of the evolutionary advantages things. And they may not have really given disadvantage or advantage, but they survived. That's also possible.
Right. Absolutely.
Yeah. Thank you. And ego thing is what you're saying. There's some person whose I should refer to for ego.
Dan Ariely, Ariely.
Okay. Thank you very much.
Sure.
Thank you, Deepika. Let me jump out to the next question. It's from Vonati. Is the brain working is normal or any functional system used?
Sorry, I didn't get the question.
Is the brain working normal or any functional system used? I don't understand the question. Vonati. So we'll give a chance to her if she's coming over to the mic, if she has permission. Then next question is from Kavya Prabhakaran from YouTube. He's asking, sir, I have a doubt. How does the title make sense? Since we are the brain, I cannot understand.
So the title refers to, there is two parts of the title and then therefore two parts of the talk. The title is you and your brain, how the brain helps you make your way through the world. So that for in terms of survival, in terms of surviving everyday life, you and your brain helps you do that. In other cases where the functioning of the brain goes against what you would consciously decide to do, that is the you versus your brain. If you're a logical, rational thinking person, but then you have biases that contradict with the rational thinking part of you, which is then you versus your brain. Your brain decides to do something which is not a decision you would have reached had you thought about something logically or rationally. That's what the title refers to.
Okay, I invite Arun to ask his question.
Yeah, good evening, ma'am. My question is, what is your take on free will and determinism? Means like whether we are free to choose, like whether we are the owner and we can free to choose what brain should do. Otherwise, there is no chance of free will. Like because our brain acts as a prejudice, like what happened in the past and what is our surrounding, the brain acts like that, or we are free to choose what we can do. So that's basically my question.
It's a loaded question, I tell you, and it's a subject of a lot of debate among scientists for a long time. So you have very polarized view in this case. There are scientists who believe that there is no such thing because your brain is wired for certain decisions and you just decide and that's what it is. But I happen to think that within the confines of what we have, we do have some wiggle room. So we are destined to have biases, but we have the choice of not going with them, realizing that those are the limitations of the processing of the system that we have. If my bias is, if you do the implicit association test, you come to know. So there is a thing of, are you biased towards people with fair skin? If you ask people, they would say, no, it doesn't make a difference. Skin color, it doesn't matter to me. But you do the implicit association test and you find out, no, a lot of us have said biases. People who are thin, people who have thin skin, hair a certain way. So we have these biases, but I don't have to go by that. I just have to realize that, yes, this is something that is, my brain has absorbed from the culture growing up because this is what we see on TV and a certain physical attributes are valued. But that doesn't mean that I consciously choose to believe all that my brain just passively absorbs. So we do have some wiggle room to choose what we choose to believe, even though the biases exist and even though there is prejudice and stereotypes there. I don't have to believe it. We run into a problem when we deny it. When we say, I'm not a biased person, then we are destined to just stay in the loop and not even get out, because we never realize that we are in this unending loop. So I think conscious awareness of it is the ticket.
So still we are the owner of the brain.
Yeah, we have to act that way. That's the thing.
Okay, actually, I'm a physics student. There is a quantum mechanics part, and general quantum mechanics is behind indeterministic. Like you can't determine first itself what is going to happen. So I just saw the video. So whether it's the brain is quite working like that, or just it's the free will is not possible. So that's basically my question.
To a certain extent, it is. I mean, it works the way it works, but then as owner of the brain, if we act that way and not become slaves to the biases and the habits that we've come to develop, we can live as the owner of the brain.
Okay. So let me jump to another question. It is from Bhishma. It's a long question. So much so for localized nature of the brain. I read the neocortex is quite uniform, and apparently the visual cortex happens to do vision just because it was connected to optic neurons. There has been instances where people were able to do some sort of vision by connecting their optic neurons to the auditory part of the brain. This is quite fascinating them from a CS point of view, as it seems that maybe there are some general principles, though which brain can learn from any type of input signal with less hand crafted machinery. So I don't understand the question.
I understood partly, so I'll answer what I could follow. So it's uniform, if you mean by how it looks, then yeah, it can look like it's pretty much the same all across, but different parts do different things. So they're not, cortex is not uniform in what different parts do. They're very functionally, it's confined. So in a normal functioning brain, no accidents, no injuries, then specific parts do specific things. Now, if there is an accident, say the part of the brain is damaged, and for this there is fascinating case studies that in the book, The Telltale Brain that I talked about, phantom brain is one such incident. So when there is a severe accident, say, which results in loss of limb, so the neurons in the brain that were getting input from that part of the body, which is no longer there, it's almost like they infiltrate the regions nearby, because nothing is coming to them. So they did I say phantom brain? I meant phantom limb. Sorry, phantom limb is the process. So there is the thing, that's a process where people report feeling sensations in a limb that they no longer have. So somebody who say has lost their left arm, when they shave the left side, left cheek, it almost feels like there is a sensation there. Somebody's touching the left arm. That's because the neurons that were receiving input from the arm now are sort of in the face of the neurons that receive input from the face. So it is localized in terms of where any part of the brain gets its input and then passes it on to others. So you have this layers of how information is organized, which is why the brain is able to do so many things. So you have information coming in, it comes in a particular part, then it is processed and sent to the other part, which will then put it together with another part. And so it's a lot of processing happens, and it is localized to different parts of the brain. So I think if I understand correctly, that's what the localization, it is very much there in the brain, yes.
So next question is from Abarna. How does the brain look for an artistic child? Why every artistic child unique?
I don't follow what I don't know what they mean by look.
That's autism. I think she's talking about autism. Right. So,
so in what I get, I mean, so they're asking what happens in the brain during autism.
Yes. Why is every artistic child is unique? It's not a.
Well, it's not something that's specific to autistic children. I mean, every brain is different. Every human being, every brain is different than the other brain. But even though we have the same hardware, because the brain is a very user-friendly organ. So depending on how you live your life, your brain is going to look different to another person. And so all the brains are different. So it's not something, the brain being unique is not specific to autism. Every brain is different.
I request Sukumar to ask the question directly. I provide permission to him to unmute his mic. Sukumar, can you ask the question?
Yes. My point is that what is the reason for this Parkinson? And now have any neurological science development with regard to its recovery from the disability?
Okay, so Parkinson's happens because deep within the brain, there is a type of neurons called dopaminergic neurons. When more than 90% of those neurons die, that's when somebody develops the symptoms of Parkinson's disorder. Reasons they die are manifold. It's not a single cause for it. So in terms of treatment, there is a treatment available. So because in the steps through which dopamine is synthesized in the brain, the medication that is given to people with Parkinson's is a step before that. You give them what's called L-Dopa, which when they take the pill in their brain, it gets converted to dopamine. So some function of dopamine is recovered, even though the neurons that make it are no longer there. So that's the first step of treating somebody. But as we have learned since, is that it's not a fix. It has downsides because dopamine does different things in different parts of the brain. In some parts you need higher dopamine, in some parts you need lower dopamine. But whereas when you take a pill, it increases dopamine everywhere. So it is good for in terms of the original problem of Parkinson's, which is movement problems. But then because it also increases dopamine in the cortex, it can lead to schizophrenia, for example, other complications because of it. But that's the first round of treatment for Parkinson's.
So the next question is from Bhishma. What is the current state of the ART-NS research in understanding human intelligence? It seems to me that there is a lot of empirical work, but with not much unifying theories.
Sorry, which field? Which system?
Human intelligence, understanding the human intelligence. NS research, I don't know, NS research in understanding
That's neuroscience research.
Oh, neuroscience research. So what do we know about intelligence? Well, it's not, what we have learned is the different ways that we have been wrong. It's not a single entity that we describe as intelligence. Kind of like how memory is, the brain classifies memory. There is different ways of intelligence as well. So intelligence has to do with, how higher, what are called the higher functions. So there is different ways that the brain processes information and gives an output. So there are different, intelligence used to be thought of as a uniform entity, but there is different, subdivisions of it, which is something that we have learned through research. What was the other part of the question? I think I missed something.
It's just that a lot of empirical work, but not much with unifying theories on that.
So I'm not the authority on that. I wouldn't know what the leading theories are on that. My understanding is pretty elementary.
Okay. So next question is, can you explain a little about the phantom limb pain?
So it may or may not be pain. It is generally a sensation. Phantom limb because it's a limb that's not there. But it happens because the neurons of the brain that were receiving sensation from that limb, which once that limb is gone, those neurons are not receiving anything anymore. It's just silent. And so as almost like a response to that, the neurons, the way it is described is that it's almost like the neurons of the brain crave input and nothing is coming that way because the limb being gone. So it's almost like they penetrate the other neighboring regions of the brain looking for an input, which is a very interesting way to describe it, I thought. So what that does is that because now, so as a result, neurons of the brain that were receiving input from the arm are now responding to input from the face because they've now sort of infiltrated on the face part of it. So every part of our body is represented on the brain, the body map it's called, but it's not in the order that we have it here. So part for the arm is right next to part for the face. So once the arm is gone, and I'm just using arm as an example here, but once somebody say loses an arm, those neurons can, and I'm not saying that happens always, but they can infiltrate the part that is next to them, which is the part of the face. So then in that case, it will manifest as the cheek is touched, but then it feels like the arm that is no longer there is being touched. Sometimes it can result in pain, but not always. Sometimes they can feel pain in the limb that is not there.
So next question is from Meena Varshini. What is the science behind addiction and brain react during R&D?
Addiction is a whole field in and of itself. So that's like a subject of another talk. But essentially that happens because the addictive substances, be it alcohol or drug, they change the neurotransmitters, the chemicals in the brain that help the brain process information. So they change the system, either causing massive amounts to be released, or so essentially in one way or the other, you'll have too much. So the neurotransmitters act like signals. A signal can only be a signal if it's there temporarily and then disappears. But what happens in case of massive amounts being released, now the brain is just swimming in so much of it. So then the downstream effect of this is enhanced so many times. When that happens, so addiction is a process. Once you release once it happens once, because somebody is an addict, they will do the same thing over and over again. So the same process happens a long time. And when that happens, because like I said, it's a very user-friendly organ. How you live your life changes how your brain is. So it essentially rewires the brain. So then the same connections crave input. So when you have, so either you will have too much of it when the drug, whatever that they're addicted to, they take that. And then when you have so much of it, then it'll just crash. So that's your withdrawal period. So essentially that happens because of imbalance in neurotransmitter systems.
Next question is from Bhishma. Given the importance of cognitive biases, do you think it would be possible to teach or train people at a scale to mitigate it?
People have been trying that. And it's not good news in terms of training yourself out of it. So we have this, we can't not have it. The only way out, I think, is be aware that when it's always there in the background. We don't have to we don't have to go by it. We don't have to believe it. Yeah, but we can't will ourselves out of it.
So next question is from Vignesh. Person with amygdala have fear, but if not, he will be fearless.
Right.
That's right. Okay. Okay. Next question is from Aparna. Is it something to do with brain that we are not forget some incident in life, however hard, we try to forget them?
So that has to do with how the brain forms memories. And we know some things about it, but not everything. I mean, there are many times, there are times we wish we forget the stuff we remember. There are times that we forget the stuff we should not have. So we don't know how the brain chooses what to keep and what not to keep. In general, though, things that have a strong emotional component to them, something, an incident that aroused strong emotions in you, we tend to remember it, even when the memory is not present. Until you process, how meditation or therapy helps us to focus on the sensation and remove the attention from the memory of it, because when you combine that with the fact that the brain cannot distinguish between something that's actually happening versus when you just remember it happen, it feels like it's really happening all over again. So the trauma of it, a lot of things happen and we forget, a lot of that does happen. But when there is such an incident of something happened that I'd rather forget, it could be because of the emotional component attached to it.
So, next question from Vignesh. Which part in brain stores memory?
That depends on what the memory is. And generally, I mean, all of the memory will not go in one piece. All of the different pieces of it go to different places. So if there is a memory of, let's say, your mom making something very delicious when you were a kid, the order part of it is filed away differently, and the emotion part of it is filed away separately, and the brain sort of puts it back together and serves it to you when you recall a memory. So where it is stored depends on what it is.
The question from Deepika: can stammering be brain dysfunctioning?
Well, it is difference in processing. So your brain processes information and then it signals the muscles to move and make the sound that you do. So any processing problem at any of the steps will result in language problems. So there were, and this is something, I mean, I don't firsthand know, I've seen this show on TV where they showed with the use of a magnet. So because our brain talks in terms of electricity, and every electric source will have a magnetic field around it. So we have a magnetic field around our heads. It's very weak, but it's there. But if you have another magnet that you position sort of about here, which is where the brain, the language part is, you can induce language defect, or you can also correct it. It's temporary. It'll last only so long as the magnet is there. But that tells us that it's possible to reorient to the system that through which we are able to produce sounds. I hope that answers the question.
Yeah, we have few questions left out. We are nearing the date. Can we extend for 5 more minutes?
Sure, absolutely.
Okay. The next question is from Guru Chandar. He's asking, is brain transplant is possible?
Not yet.
Ma'am, next question is Bond. Kindly explain about neurotransmitter and their functions.
There is many kinds of neurotransmitters in our brain, and essentially this is a chemical that one neuron uses to talk to the other neuron. The neuron it's physically connected to, that are physically close to it. You can have neurons or neurotransmitters that turn up the message. So it's like cranking up the volume on your TV or your radio. Whatever the message is, it's coming out louder, it's being enhanced. Or you have the flip side of it, there is the inhibitory kind, which is like the mute button. So you need both, and you need a balance of both for the brain to actually precisely process. If you have excess of one or the other, that results in diseases.
The next question is there any kind of internship on neuroscience available at the moment for graduates?
I'm sorry, I missed the word there. Any kind of?
Internship.
Internship in neuroscience, I imagine? Is that what?
Yes, yeah.
Well, right now, difficult because of COVID, but otherwise, yeah, you simply write to the labs whose work interests you, and you just, you spend some time with them over a break or something. We don't have I'm not aware of in India a formal system of internship, but essentially that's what happens is that students come to our lab to spend some time to learn about the research over any breaks they have.
So next question is from Bala. Gossip is a product of confirmation bias in social living.
I'm sorry, I missed the first one. What
Gossip. Gossip,
okay. Gossip is the product of?
Product of confirmation bias in social living.
Why do we gossip? Well, it's guilty pleasure. You get to be the judge for another person's life, and it gives us a sort of, and this is just my view, not based in any science. Just my personal view. We feel good about ourselves. It's a way to put attention away from our own flaws, which are aplenty in all of us, and direct it towards somebody else and saying, they didn't do this, and you know what they did, and okay, can you believe? We get to judge, we get to talk about somebody else and pass judgments without, and gives us a sense of superiority about ourselves.
The next question, the question it was asked by Aditya Verma on redundancy. He says that there is a general notion that even an intellectually active person uses very small capacity of the brain. Why so much redundancy?
No, that is not true at all. Not true. We all use all of our brain all the time. It is not true that we use only, this is one of those things, one of the myths that just refuses to die. So let's just all take a combined pledge and kill it. It's not true. We use all of our brains, all of us.
So next question is frog can survive. If frog can survive without brain?
Briefly. So there is as in there will be activity. The spinal reflexes, you'll see some activity, some movement in the muscles, even once the brain is not there. We have it too. So spinal reflexes do not require the brain. The brain is informed after the fact. So even in somebody who's brain dead, you can still have spinal reflexes. That's pretty much it, but that's temporary, and that's, eventually either the brain, the cells run out of energy, and that also stops.
Okay, Nakarani has raised her hands, and I just unmute her mic, and she can ask question. So we are running short of time. Be brief about the question.
Okay, I just like to know how does the brain work for a premature baby?
Depending on when how much premature the baby is, that means that in a normal term of pregnancy, the brain is at a certain point in development at the time of birth. So there can be complications, or not necessarily. It's not necessary when a baby is born before their due time. It's not necessary that they will have in long term, but it is possible. Depends on when, how much before their due time, and what possibly the cause of the premature birth.
So next question is, are there really brain foods to improve memory part of the brain?
Brain foods.
Food.
Well, so not a one-to-one relation in terms of if you eat this, your memory will be good. To have a good memory is more to do with lifestyle. Of course, healthy diet is part of it, but it's not like eat this and then nothing can beat your memory. It's more like, what's your general stress level, and do you feel overwhelmed? And those are the kind of things that hamper either formation of memory or retrieval of memory. So for good memory, I would say look at your lifestyle also.
Okay, so we are reaching 5. Well, Lara, there are a few more questions left out. Can we go ahead and we'll close it?
Sure.
You don't have any. So what is your opinion on brain-gut connections? Can improving the gut health improve the brain functions?
Right. So there is a lot of evidence to suggest a link between how. So this is when we say you are what you eat, this is what it is referring to. When, depending on what your diet predominantly is, the flora, the bacteria in the gut will be different. And they also release a lot of the chemicals, which then feeds back to, has an influence of how the brain works. So yes, there is a very strong connection, and yes, they do influence the functioning of the brain.
Again, I think the question is another question, which is repeat. Let me read it. Which part of the brain is responsible for remembering or forgetting?
So when we're talking about recalling something, then again, so hippocampus is involved in learning and memory. It is the part where memories are formed. But once they are formed, your brain has to decide, do I keep it or get rid of it? We don't know all that goes into the brain making this decision. But once a decision is made to file away the memory, where it is stored depends on what it is. Is it so emotional memory, physical components of it all get filed differently. So it's not like, when you record something on your phone and you play it back, all the entire video is in one place. The brain does not file memories that way. Different pieces get stored in different places in the brain.
So this is from Mr. Ramaswamy. He's asking, is there any way to prevent dementia in old age?
Prevent dementia. So so a lot of things affect how dementia manifests. Long term, of course, your diet is a factor. Also, to keep your brain active, that also plays a role. So if you're an active person, not only in terms of physical activity, but also you keep your brain active. You do things that you enjoy. You do things like puzzles or crossword or something, things that you enjoy. You meeting other people, because we're social primates, right? So that has a big impact on how dementia manifests. So yes, there are things to.
Yeah, we have 3 more questions. Last question will be asked by Manoj. The next question is, Bhishma, do you think psychology and neuroscience would converge in future? Is that the goal of neuroscience?
The future is now. They have already converged. Okay. That's what we do. I'm a neuroscientist and I work with psychiatrists who are clinicians who see patients. I don't see patients, but then we work.
No, she's asking psychology.
Psychology. Well, yeah. So again, there is psychology. You're studying at behavior, which may not necessarily be a disease, but then this is the outward manifestation of why, the motivations behind behavior and all that. And so, if you want, there is value in that, but then at some point, I think that to look at the hows and the whys of what in the brain is leading to that behavior, that is already happening. The technology for that is already here.
The question is from Aparna. Why do we feel some situation has already happened when it is actually happening? The deja vu feeling.
Deja vu. I am not clear of the neuroscience of it, but I suspect it is, maybe it has to do with the memory retrieval, like some component of what's happening reminds you of something else, but it doesn't come up as a memory, it comes up as actually happening. So I suspect it is related to, and I could be completely wrong on this, but I suspect that it could be related to why the brain cannot distinguish something between the feeling as a result of recalling a memory versus actually experiencing something. I suspect it's a cross-wiring.
What are the systems that can functionalize the brain? Functionalize the brain.
I'm not sure.
Okay, let's leave it. The last question is from Manoj. I'm just opening his mic and he can ask the question directly. He has a couple of questions in the chat box and he also wants to talk directly. Manoj, are you there? Okay, let me read the question from Manoj. Is there any trick to induce the brain to help recall something which I am not able to recall easily?
Well, if he learns of this, please let me know. I struggle with that a lot. No, not that I know of.
Hello.
Yeah.
Are you able to hear, sir?
Yes.
Yeah. Good evening, Reeteka madam. Yeah. Hi. My second question is like, I heard that the human brain will grow the entire lifespan of the person. Is it true? Like,
parts of the brain. So it not grow as in physically in size, but there are cells that keep dividing and keep replacing. So it changes throughout the brain. Yes, throughout the life.
Okay. Other question you didn't answer. Like, is there anything to make the brain recall some memories which I'm not able to?
I did say, if you hear of something, do let me know. I don't know of anything that can specifically do that.
Oh, specifically. Okay. Thanks a lot. Thank you.
Thank you all. We are closing the question answer session because all question has been answered, and let us close it now. We have already exceeded 10 minutes. I would like to thank Reeteka ma'am for giving a wonderful lecture. Apart from the wonderful lecture, she has passionately answered all the questions, and thank you very much, ma'am. And also thank all the participants, and also thank my colleagues and friends who has helped me to make this event happening. Thank you very much. My special thanks goes to the Dr. Ramanujam, who is not here. He has gone to another meeting. He has organized the speaker, and my thanks to Ramanujam as well. Thank you very much. Let us close this session. Thank you very much.
Thank you all.
Thank you.